Hello dear students, in this lecture I'm going to explain the introduction of the capacitors. So the reference book is Giancoli, Physics Scientists for Engineers. Okay, now chapter number 24. In this lecture we are going to start the chapter number 24. So first thing is the capacitor, topic number 1. Lecture number 1, chapter 24, capacitors. So basically capacitors are devices, electronic devices that can store electric charge. They are used to store electric charge. Capacitors are widely used in different electronic circuits. They can just like they also such as flash camera, camera flash, energy backup in computer, and all other different applications. So let me explain the basic construction and working of these capacitors. So basically the simple construction, capacitor is the simple construction is the parallel plate capacitor. Parallel plate capacitor is one of the simple type of capacitor is parallel plate capacitor. So capacitor A has two plates. Capacitor has two metal plates, and these two metal plates are separated by distance d. These two plates are separated by distance d. Okay, so this is simple capacitor, simple parallel plate capacitor. It has two plates. So when we connect in the circuit, so the symbol for capacitor is like this. This is the symbol of capacitor. Simple two parallel lines just drawn. See the symbol of capacitor, or sometimes we use this symbol. This is also the capacitor. Okay, so if we want to connect the battery, so the battery symbol is like this. Cell or battery has a symbol this, plus and minus. This is battery symbol, and this is the capacitor symbol. Okay, so now how capacitor stores electric charge. So let me explain this. So basically when we connect capacitor, two plates of the capacitor, one plate is connected to the positive terminal of the battery, and other plate is connected to the negative terminal of the battery. So the one plate stores positive charge on it. We say that plus Q charge is stored on this, because battery provides the charges. Batteries provide energy to the charges, and these charges are stored to the plate, lifted to the plate. So the other plate stores a negative charge, and equal amount of a negative Q that is stored on the other plate. Okay, so as we know that how the charge stores, main thing is the how charge stored on this capacitor. So charge is stored by, basically there is separation between the plates, there is a gap between the plates. So when there is a space between the plates, the electric field E is developed between positive and negative terminals. So we know that when we have positive plate and the negative plate, so electric field intensity E is developed between the plates, and this electric field intensity will attract, due to this electric field intensity there is a potential that is developed across the plates of a capacitor. So we can say that this positive and negative, they attract one another. They attract one another. Negative plate attract positive plate, and positive plate attracts a negative plate. But as we know, the charges on these plates attract one another. So as there is a space between them, there is an infinite resistance between them. So the charge will not leave the capacitor plates until you discharge this. So this is the charging process. When you connect a battery of voltage V, the charge is stored on the capacitor. Okay, so it is experimentally observed that the potential V is proportional to charge Q. What does it mean? It means that if you use battery of higher potential, the charge will be higher. The more charge will be stored on the capacitor plates. So we can say that potential is proportional to charge. So let me remove the proportionality. Then we can write Q is equal to. We can say that Q is also proportional to V. V is proportional to Q, or Q is equal to proportional to V. So if we remove the proportionality, so we are left with the constant of proportionality CV equal and C is the basically capacitance of a capacitor. Capacitance of a capacitor. What is capacitance? So capacitance is basically ability of a capacitor to store charge. Ability of capacitor to store charge, and this ability C is can also be we can write this Q over V, because if we rewrite this equation, Q is equal to CV and C is equal to Q by V, and its unit is in farad. 1 farad is the unit of capacitance, that is equal to 1 coulomb per unit 1 volt. 1 coulomb per volt is known as the farad. So the ability of a capacitor is measured in farad. How much capacitor is its ability is measured in the farad. Okay, so so we can say that this is all about the construction. Okay, working and the construction of the symbol. So basic introduction of the capacitor. So capacitor is a device that stores electric charge. And how charge is stored? We connect capacitor with the battery of potential V, so that the charge is lifted towards the plate, and then charge is stored on them, because there is electric field E between them, and that's why the potential is developed across the plates, so that the charge can store on the capacitor. Okay, thank you.